how two markers can help you to explain the concept of the CML as well as CLL, which I will do later, that I'm going to demonstrate today. So let's say this is a person's, normal healthy person's chromosome number 9. And in this chromosome number 9, what is there? There is a ABL gene is there. Let's say this cap is ABL gene, ABL1 gene they say. And this ABL1 gene is a proto-oncogene. Proto-oncogene is always present in everyone. Actually, it's quite natural, actually, normally present. But if this proto-oncogene is converted into oncogene, then it causes problem. You are aware of all these basic concepts. So what happens in this normal chromosome number 9, they have this ABL1 gene. And this ABL1 gene has tyrosine kinase property. It helps in cellular growth, cellular differentiation. But this is under control. That means they cannot cause cellular differentiation, cellular proliferation all the time. This is usually switched off mode, and it can be switched on. How this switch on and off is controlled? There is a domain here in this ABL1 gene, which is called SH3 domain. That SH3 domain is a negative regulator. It keeps it switched off mode. That is the idea. Now, in our chromosome number 22, there is another gene there that is called breakpoint cluster region gene. So this is chromosome number 9 and this is chromosome number 22. 9 has ABL1 gene, chromosome number 22 has BCR gene. In case you are confused that which one is in 9, which one in 22, you can think in this way, that in alphabetically A comes earlier than B and 9 comes before 22. So ABL1 would be on 9 and BCR would be on 22. This is a easy way to think in this way actually. Now what is happening, that translocation occurs in this patient who develop actually the CML particularly. So what is translocation? What is meant by translocation? Translocation, you can think in this way, that just two parts of the chromosome, they swap with each other. So let's say this black cap comes to this blue marker pin and this blue cap comes to the black marker pin. So what is happening, that some part of the chromosome number 9, they are swapping with some part of the chromosome number 22. So let's say this is the unbroken segment of the chromosome number 22. And in this unbroken segment of the chromosome number 22, what is happening? A part of the broken part of the chromosome number 9 is coming and fixing with each other. And let's say this part of the broken part of the chromosome number 9, that contain the ABL1 gene. Now this ABL1 gene is coming, and in this unbroken segment of the chromosome number 92, it is getting fixed. So what is going to happen after this, that this ABL gene is going to juxtapose on the BCR gene, and they're going to fuse with each other, creating a fusion gene, which is called ABL1 BCR fusion gene or ABL BCR fusion gene. This fusion gene is the culprit gene, which is basically causing the CML development. Why it is causing CML development particularly? The reason is that I mentioned you that this in the ABL gene, they are basically negatively regulated by SH3 domain. So this is this gene is a proto-oncogene, and it has tyrosine kinase property. It can cause proliferation, growth of the cells. But what is going to happen? This is under the shackle of the, I would say, of SH3. So SH3 controls its leads. You understand that SH3 don't allow that is always switched on, always causing uncontrolled proliferation. But when they fuse with this BCR gene, this product is created, the fusion gene. ABL gene loses its property that SH3 controlled. SH3, I would say in this way, that SH3 region cannot control or cannot negatively regulate this ABL gene anymore. That property of the SH3 domain is disappears actually. You can think in this way. So what is going to happen, that SH3 does not. So when ABL1 fuses with BCR, now this ABL gene's tyrosine kinase property is on switched on mode, and they're going to cause always uncontrolled proliferation of the cells. That's why actually it drives the bone marrow to cause uncontrolled proliferation of the myeloid cell elements. Now this ABL BCR gene fusion, obviously gene are going to produce a protein. So gene is like a recipe book, I think, and the cooked product is the protein. So obviously ABL BCR, this fusion gene, is going to create a protein also. That protein would be ABL1 BCR protein. This protein can be of 3 types actually, depending on the region where this BCR gene has been BCR, the breakpoint cluster region, they have fused actually, where this where they have broken. That is the basic idea. So one kind of protein which is commonly seen, which is typically seen in the CML, they have 210 kilodalton molecular weight. So this is called 210. I think you've read on these books. Also, in majority of the cases of B cell ALL, we see 190 kilodalton property of this. In some cases, we can see some rare myeloproliferative neoplasm, we can see 230. But typically, the protein which we see, that is ABL BCR protein with 210 kilodalton molecular weight. But they can be of three types, as I mentioned, usually described. And so that is the basic idea of the CML. And there's an interesting story also that how this was discovered and what is actually called Philadelphia chromosome. Philadelphia chromosome is this chromosome actually. The abnormal Philadelphia chromosome is not translocation 922. Philadelphia chromosome is this abnormally shortened chromosome number 22. Why it has become abnormally shortened? Why? Because the portion of the chromosome number 22 which has been broken, it is of higher greater length, and it is replaced by a shorter segment from the chromosome number 9. Let's say you have a 5 centimeter pencil. I break 3 centimeter out of it and replace it by 1 centimeter. So what will be the total length of the pencil? 2 plus 1, 5 minus 3 is equal to 2 plus 1, 3 centimeter. That means if I take out a bigger chunk of that pencil and replace it with a smaller length fragment, obviously its total length would be decreased. So that's why actually the chromosome number 22 becomes shortened in this patient. And this abnormally shortened chromosome number 22, which has that abnormal fusion gene, BCR1 ABL gene, this is called Philadelphia chromosome. Why? Because there are two distinguished gentlemen. One is David Hungerford and his professor Peter Noel. They basically described or discovered this abnormally shortened chromosome in CML patient in the city of Philadelphia, and that's why it is called Philadelphia chromosome. This happened in 1959, and it also was discovered through an accident. Peter Noel, who was a professor, one day he was in a hurry, so before going back home, he actually processed the tissue because he was actually at that time monitoring this CML cells actually. Processed the tissue rather than following the standard protocol. He took a shortcut. He processed the tissue in tap water, and next day when he saw the cells, actually observed the cells have swelled up. Now he was not so good competent in interpreting this means chromosomes. So what he gave those things to his actually a student who was working under his guidance, that is David Hungerford. And David Hungerford was very skilled. So when he looked at the slides, he found that all these CML patients, their chromosome number 22 is abnormally shortened. And then he told this to his guide, actually, Peter Noel. And then they found that actually all CML patients, they have this chromosome number 22 is abnormally shortened. And this abnormally shortened chromosome number 22 was called Philadelphia chromosome. And the actual reason was actually discovered 14 years later by Janet Rowley. He found that this missing piece, why this chromosome number 22 is shortened, it is basically there in the chromosome number 9. And they found that the reason for this is the translocation. So translocation number 922 is the cause, and the effect is the shortened chromosome number 22. And this shortened chromosome number 22 is called the Philadelphia chromosome. That's the basic idea. Thank you so much.